Okay, so what are the best strategy when you want to draw isomers? So the type of isomers that you want to check for are structural isomers, so trying to bond things differently. For example, different branching, or if you have a substitute like a fluorine or a chlorine, try to put it in different places. And if you have double bonds, you want to check if you have cis and trans isomers. If possible, there may be different type of rings that you can make. Now, if you have rings, you could also have cis and trans, but I will not ask you that particular instance. So read carefully what type of isomers they are asking you to draw in the questions. I will not ask you for sure to tell me how many isomers. When I'm asking you how many isomers you have, I will not ask you to count enantiomer. So if there is chirality, I will not ask you that. Okay, so let's see possible scenarios. So first thing that you need to start asking yourself is if that hydrocarbon, so in this case it's an hydrocarbon, there are no other atoms other than carbon and hydrogen, is it saturated or not? What does it mean? If it's saturated, it's going to have as many hydrogen as you could fit with a particular number of carbon, in this case 6. How do you know that? You need to look at this formula, CnH2n plus 2. So if it's saturated, for 6 atoms of carbons, the number of hydrogen should be 2 times 6, 12, plus 2, 14. And that's the case. So I know that this is saturated, it's an alkane. That means that there are no double bonds, no triple bonds, no rings. Because if any of those structures would be present, you would have less hydrogen. So really the only thing that you can have here is branching, different type of branching. So start by writing the one that is sort of linear, so hexane in this case. So 1, let's say 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. So let's put number 1, 2, 3, 4, 5, 6. So this is hexane. And if I really want to stress the fact that it's linear, I can call it N-hexane, normal hexane. And that's 1. So that's my compound number 1. Now keep in mind, it's in the exam it's going to be a multiple choice, so you don't have to draw really anything, unless they ask you how many, and the possible answer are numbers, in which case you need a piece of scrap paper and draw something. Now, one thing that I can do now is proceeding with order, otherwise you risk to have duplicates. And what you want to do is start taking away one carbon at a time. So if we take away one carbon, we have 5. So the chain is going to look like this. So this is a chain of 5. Where am I going to put carbon number 6? Let's see, I could put it here as a branch. So that would be, so that's 1, that's 2, right? So this is going to be 2-methyl pentane, because you have a methyl in position 2 on a chain that is a chain of 5, so it's pentane. Can I put that methyl in a different position? Well, what about I stick it here, right? So that would be 1, 2, 3. So that would be 3-methyl pentane. Now, can I, so I figure out a second isomer, and I figure out a third isomer. Now, can I have a, so this is 2-methyl pentane, and number 3 is 3-methyl pentane. Can I have a 1-methyl pentane? So let's draw pentane. So 1-methyl pentane would mean, and I'm going to put in a different column, that the methyl would be here. But then this is not 1-methyl pentane. This is back to a hexane. So you have already drawn that. So that's not a real thing. That's not an alternate isotope. Can I have 4? So I have my pentane. Can I have a 4-methyl pentane? That would be 1, 2, 3, 4. But that's not for methyl pentane, because I would have to start counting from here so that my branch has the lowest number, and then I go back to the 2 methyl pentane that I've already drawn here. So this is not good. This is not a possible isomer either. So I really have only those, right? So to find more, I can just keep taking away carbon. So now instead of a chain of 5, let's make a chain of 4. 1, 2, 3, 4. So that would be butane. And now I have 2 carbon of atom of carbons that I need to put somewhere. So let's put one here and one here. So that would be so 1, 2, 3, 4. That would be 2, 3 dimethyl butane, and that would be my 4 isomer. Can I put those methyl differently? Right, so if I have butane, is there a different way to arrange them? Well, I could stick them to the same atom of carbon, in which case it would be, again, 1, 2, I always want the lowest number, so that would be 2, 2 dimethyl butane. Can I have 3, 3 dimethyl butane? 1, 2, 3. Well, no, I really can't, because the proper way to put the numbers on this structure would be to start from here, and that would become 2, but I already have that compound, so this is not acceptable. Or maybe I could have 1, 1 dimethyl butane. So this is my butane, and then I stick, and I put them in different colors so you can see them. I stick to the 2 methyl in position 1, right? But then the number 1 is this, because it's 1, 2, 3, 4, 5. So that would be 2 methyl pentane, but I've already that was my number 2 here. So this one is another one that doesn't work. Okay, so I really only have 5. If I try to make it with 3, right? So if I try to make a structure that has propane, so 1, 2, 3, then I have 3 atoms of carbons that I need to connect. So I could put one here, I could put one here, but then where am I going to put the third one? Because each carbon can only make 4 bonds, so necessarily I need to go here, but then those numbers don't work anymore. This is going to be number 1, this is going to be number 2, it's going to be number 3, and whatever, each of them can be number 4. So this is butane. This is actually I would have to start from this end, so that would be 1, that would be 2, that would be 3, and that would be 4. So that would be 2,2-dimethyl butane. That was compound number 5. So really I'm done here, and all the isomers that I can actually write are only 5. Is there any chiral atom of carbon here that I could could generate more isomers? Not really, because remember that there are atoms of hydrogen here, so even if you see only 3 bonds here in this, there is a hydrogen here, right? So those angles here are drawn as 120, but this is not trigonal planar. There are 4 bonds, and therefore the hybridization is sp3. This is a tetrahedron. So the first condition that you need to have a chiral atom of carbon is to have an sp3 hybridization, to have 4 separate bonds. And then the 4 things connected to the carbon needs to be different. So here you have 1 hydrogen, 1 methyl, and another methyl. So these 2 being identical, that it takes away the possibility of chirality. Same thing happens here, because you have 1 hydrogen, but then this is a methyl, so these 2 are different, but then these 2 are ethyl and ethyl, so there is no chirality. Okay, so let's see another example. So is this saturated or not? So again, same formula. This time with 4 atoms of carbon, if it would be saturated, I would have 4 times 2, 8 plus 2, 10. And so I have 2 hydrogen missing. So it's not an alkane. So every 2 hydrogen that are missing could be a double bond or a ring. If you have a triple bond, you're going to have 4 less hydrogen. So you still have too many hydrogen for a triple bond, but you have the fact that there are less hydrogen that you would expect based on this formula is telling you that you have either a double bond or some sort of ring, one or the other, not both of them at the same time. So let's see what are the options here. So let's start with the linear chain of 4, right? So we know that we have to put a double bond. So first of all, we are going to have some variability depending where we put the double bond. And those would be structural isomers, because the connectivity is different. Then, with the double bond in the same position, we need to check if there is a chance that we have cis or trans isomers, because that would increase the number of isomers. So where can we put, so we have butane, right? Where can we put the double bond? We can put the double bond at the end of the molecule, or we could put the double bond in the middle, right? So 1, 2, 3, 4. So this is going to be butane, and it's going to be 1 butane. This is going to be 2 butane. However, here I have, it's not really explicit, but there's going to be a hydrogen here and a hydrogen here. So I have the 2 hydrogen on opposite side and the 2 carbons on opposite side, so this is trans. And I could have the cis. That would still need to have the double bond right in the middle between carbon 2 and carbon 3, but it would be flipped like that, so that the 2 methyl are on the same side and the 2 hydrogen are on the same side. Okay, so we have 1 possible isomer for the 1 butane. So 1 butane and 2 butane respect to each other are, so if I'm comparing these two, these are structural isomer. If I'm comparing these two, these are geometrical cis-trans isomer. So all in all, I have 1, 2, 3 compounds. I can really put the double bond in position 3. That would be 1. So I have my butane, right? 1, 2, 3. So that would be this. This is identical to the first structure that I wrote, just flipped. So this is not anything different. Okay. So how about maybe I shorten the chain to 3. And then I need a double bond. So left or right, it's not going to make any difference. So this is going to be propene, right? And then I need to put somewhere a branch made of 1 atom of carbon. Now I cannot put it here, right? I'm going just to, because if I put it here, I'm going to go back to the compound that I've already written. So the only other place where I can put it is this, right? So let's rewrite it. With this, let's cancel that. So this is going to be propane, 1, 2, 3. Right? So that's going to be 2 methyl I'm not going to write the whole word methyl, 2 methyl, 2 propane. I would have to start counting from here, so right, 1, 2, 3. That would be the proper way. Okay, so far I have found 4, but instead of having double bonds, I could have a ring. So how would that look? Well, with 4 carbon, I could make a ring of 4. So that would be like a square, right? So that would be cyclobutane. Not many options there. There's only one way to draw it. Or I could make a ring of 3, right? So that would be cyclopropane. But then I have an extra carbon, and really whatever I put it is going to be 1. So there's our other 2. So this is compound number 4. This is isomer number 4, and this is isomer number 5. Okay, so let's see this one. For the left side of the screen, we want to figure out if any of those atom of carbons is chiral. So you have a carbon here, right? Let's make explicit all the hydrogens. So I want a penta. Okay, so we have 1 hydrogen here, 1 hydrogen here, and 1 hydrogen here. And you always want to check that the total is 4, right? So here in this intersection we have 3 bonds, so there is 1 hydrogen here, 1 hydrogen here. Here is going to be 3 hydrogen, and here is going to be 3 hydrogen. So in order to have chiral atom of carbon, to have chirality, I need to have 4 different things. So let me grab an highlighter. Let's start. So obviously I'm not even bothering looking at these 3 actually terminal, because obviously there's 3 hydrogens that are identical, so those are not care of by any means. But what about this, right? 1 and 2. There's potential here. So let's look at this one. I have 1 hydrogen. Let me get the pointer. Okay. So I have 1 hydrogen. Here I have CH3. Here I have a more complicated branching. And here I have bromine. So yes, this is going to be chiral. And so typically you do that by putting an asterisk, star. This one, let's go back to the pointer. So again, this is chiral because there are 4 different groups. If even 2 are identical, then that takes away the chirality. So here you have an hydrogen, but you see you have the same thing on top and right. So this hydrogen here, this carbon here is not chiral. Now in this part of the screen, they want you to write. The question would be, write all the isomer for that formula. So let's start by writing a chain of 5. 1, 2, 3, 5. Okay, so that's 1, 2, 3, 4, 5. Now, for a chain of 5, if it's an alkane, we would expect 10 plus 2, 12 hydrogen. We have only 11, but that's because there is bromine. So wherever bromine goes, takes away 1 hydrogen. So this is an alkane. There is no way I can have double bonds or rings. So the only really things that I can play around is where I put the bromine, right? So let's start by putting the bromine, let's say here. So that would be 1. That would be 1 pentane, 1 bromopentane. Then I could put the bromine here. So that would be 2 bromopentane. And I could put the bromine here in the middle. So I have 1 bromopentane, 2 bromopentane, 3 bromopentane. Can I have 4 bromopentane? No. If I try to write 4, so that would be 1, 2, 3, 4, right? So I would have to put my bromine here. But if I count from the other side, that's 2 bromopentane that I've already, so these two are identical. So I'm not writing anything new. As well as 5 bromopentane is not an option. So basically you have only 3 possible isomers for that.